Hello everyone. Hang on. Look at what we have on the board. Square root of minus 1 raised to power square root of minus 1. This looks very dangerous. How do we solve this? Okay. Now, in complex number system, we often write square root of minus 1 as I. So square root of minus 1 raised to power square root of minus 1 is essentially I raised to power I. A purely imaginary complex number raising to power another purely imaginary complex number I. Okay? Now, it will interest you to note that, do you know that the answer to this is a real number? Follow me, let's find out. Okay? First, what we have to do, we have to express the complex number I in what we call the exponential form. Okay? So for you to be able to do that, you have to get what we call the modulus and the argument of the complex number I. Okay? So this is the Argand plane or the complex plane. So we call it Argand plane. Okay? The Argand plane. Now, let's represent the complex number I on the Argand plane. Okay? This is the imaginary axis and this is the real axis. Okay? Now, to find the argument of the complex number I, you check for this line from the origin to the complex number I and the positive real axis. What's the angle here? The angle here is nothing but 90 degrees. Okay, so here is 90 degrees, or we call it what? Pi over 2. Okay, pi over 2 radians. So now what is the measurement? What is the length from this 0, the origin, to the complex number I? It is nothing but 1. Okay, so with that we find out that the complex number I is equal to this modulus, which is 1 times exponential I, the argument, pi over 2. Okay, so the complex number I is actually 1 times this is still exponential I pi over 2. Okay, but for the sake of completion, we have to write this as exponential I pi over 2 plus 2k pi. Okay, why we wrote 2k pi? 2k pi is 2 pi is like 360 degrees, so 2k pi is integral multiple of 360. Okay, so k is an integer. K is an integer, so k is in the integer z. This is a set of integers. Now substitute this into here. Okay, so we have what? This will be equal to exponential I pi over 2 plus 2k pi. Okay, then raised to power this I. Okay, now by law of indices you multiply these two powers. So this is what? Exponential I times I is I square into pi over 2 plus 2k pi. Okay, now what is I square? I square is minus 1, so this is exponential minus pi over 2 plus 2k pi. K is an integer, z. Okay, so I raised to power I is equal to this. Okay, so since k is an integer, this value is infinite. For every value of k, this changes. Okay, so for instance, if k is 0, you find out that I raised to power I will be what? Exponential minus pi over 2, then plus 2 times 0 pi. So this will be 0. So this is exponential minus pi over 2, which if you press in calculator, you get what? 0.20788. Correct to 5 decimal places. Okay, for k equal to 1, you get another value of I raised to power I. For k equal to 2, you get another value. For k equal to even minus 1, minus 2, you get infinite values for I raised to power I. So in conclusion, I raised to power I will give you a real number. Okay, therefore square root of minus 1 raised to power square root of minus 1 will give us exponential minus pi over 2 plus 2k pi. Okay, where k is an integer. All right. Thank you so much. See you next time.